So this question starts off by providing us with this equation here. N of d is equal to 115 times 0.9 to the d power. Just as a frame of reference, anytime I see a question that has a variable in the exponent, I'm always thinking about, well, what does it mean for that exponent to be 0, right? So what would it mean if d were equal to 0? Because if d were equal to 0, then 0.9 to the 0 power just becomes 1, and that would mean that n of d, or really n of 0 in this case, would equal 115. Okay, so let's see what this question is telling us and see if there's any value to having that knowledge. So the question says the function n defined above can be used to model the number of species of brachiopods at various ocean depths, d. Okay, so that means at the ocean depth of 0, right? So basically on the surface, there are 115 brachiopods. Where d is in hundreds of meters, all right, which of the following does the model predict? So choice A, for every increase in depth by 1 meter, the number of brachiopod species decreases by 115. Well, that, first of all, that doesn't seem to be true at all. But second of all, we can definitely test it, right? Because we could say, well, when d is equal to 0, we get 115. But when d is equal to 1, we'd get whatever 115 times 0.9, right? Because 0.9 to the first power is just 0.9. Then we can go to our calculator and figure out what that is if you wanted to. And you see that that value is 103.5, which means that we've gone from having 115 species to 103.5 species. But this is saying for choice A that an increase in depth by 1 meter, the number of brachiopod species decreases by 115. So that's not true, right? That's not a 115 decrease. So choice A is gone. Choice B, for every increase in depth by 1 meter, the number of brachiopod species decreases by 10%. Okay, well, let's see. What is 10%? Is this a 10% decrease? I think it is, right? So 10% of 115, obviously here, 115 times 0.9 represents a 10% decrease. So I like that. So B sounds good. How about choice C? For every increase in depth by 100 meters, the number of brachiopod species decreases by 115. So if I went to D equals 100, right, and I had 115 times 0.9 to the 100 power, again, I can figure out what that math is. I don't think this is going to work out. This seems like it's a bit too high, but we can always figure out what it would be. So I go to my calculator. I'm going to type in my 0.9 to the 100 power and multiply that by 115. And no, right? So that's not, I'm not getting a decrease of 115 for that. So choice C is gone. Choice D, for every increase in depth by 100 meters, the number of brachiopod species decreases by 10%. Okay, so we have this decrease by 10% thing again. And now I'm making sure, oh, I think I missed something there. Okay, so that makes sense. So the question says where D is in hundreds of meters. So that's important, right? So when I'm saying D is 1 here, that actually means D is 100. So the information, so this minus 10% really goes along with the depth of 100, which makes choice D better than choice B, right? Choice B is representing depth by 1 meter, right? Which means that would be tested by saying D is equal to like 0.01, 100th, right? So 0.01 would be the way to test this. So that's the reason why D is a better answer than choice B is. Although this is a bit tricky, right? So we have to pay attention to the wording. D is in hundreds of meters.